Okay, so hi there, folks. So we're going to continue our videos in fundamentals of mathematics, and in this video, we're going to talk about more rules in divisibility. And actually, this will be the last video for my set of videos in rules of divisibility. And here, we're going to tackle the last parts or the last numbers that we're going to be learning, in particular 10, 11, 13, and 17. Okay, and yeah, we're going to start with our first two rules in divisibility. I'm going to somehow just present to you the number 10 because not going to really explain it a lot because it's very trivial to know the divisibility rule for number 10. So the rule for number 10, if it is if the last digit is 0, so of course it is divisible by 10. For example, 130, the last digit is 0, so it is divisible by 10. So that's very trivial for us. So any number ending with 0 is divisible by 10. How about for number 11? So this is a very interesting way to determine if 1 is divisible by 11. So what will we do? If the difference of the sums of digits in odd and even places is either 0 or a multiple of 11. So if that's the case, we can say that this number, the original number, is divisible by 11. Again, add all the odd places, add all the even places, get their difference. If it is 0 or 11, it's a multiple of 11. Or we can think of it this way. Since we're adding the odd places minus the even places, maybe we can just, um, what do you call that? Alternatively, add minus, add minus, add minus numbers. And then eventually we will end with an integer, and if that number ends with 0 or ends with a multiple of 11, 11, 22, 33, so that's indeed a multiple of 11. For example, we have 6,875. So what we're going to do is we're going to minus first 6 minus 8, that's minus 2. 2 plus 7 plus this time. 2 plus 7 is positive 5. 5 minus 5 is 0. So indeed, this number, 6,875, is divisible by 11. Another example, 40,359. So let's do it. 4 minus 0 is 4. 4 plus 3 is 7. 7 minus 5 is 2. 2 plus 9 is 11. So therefore, 40,359 is a multiple of 11. And lastly, 76,285, is it a multiple of 11? We can see, but let's try to do the calculation, shall we? 7 minus 6 rather. 7 minus 6 is 1. 1 plus 2 is 3. 3 minus 8 is negative 5. Negative 5 plus 5 is 0, so that's why it's 0 here. And yes, it is, therefore, it is a multiple of 11. Okay, so let's start with our exercises. I'm going to present here only 3 and try to answer if these are multiples of 11 or not. Okay, you can pause the video now. Okay, so let's try to answer this. So what we're going to do, we're going to follow this pattern to determine if it is divisible by 11. So clearly, all of them are not divisible by 10 because they all end up with 4. So let's see. 2 minus 6 is minus 4. Minus 4 plus 4 is equal to 0. So indeed, it ended with 0, so therefore it is divisible by 11. Okay? Number 2. 5 minus 7 is minus 2. Minus 2 plus 4 is positive 2. So didn't end up with 0 or any multiple of 11. So therefore, this number, 574, is not a multiple of 11. Okay, how about number 3? 8,954. So let's do the same pattern again. 8 minus 9, that's minus 1. Minus 1 plus 5, that's minus positive 4 rather, positive 4. 4 minus 4 is 0. So therefore, this number is, yes, this is a multiple of 11. 8,954 is divisible by 11. Okay, so that's how we know if one number is divisible indeed by 11. Let's move on to the next one. Now, how do we know if one number is divisible by 13? Okay, similarly, we follow the pattern with the divisibility by 7 here. Only that it's not going to be twice. Okay, it's not going to be twice. It's going to be 9 times the last digit. Okay, so let me read that. If the difference between 9 times the last digit and the other digits is divisible by 13, so indeed that number will be divisible by 13. So 9 is the multiple. So for example, 741, so our last digit, our ones digit or our units digit is 1. 1 times 9 is 9. Deduct 9 from 74, that will give us 65. And yes, 65 is divisible by 13 because that's 13 times 5, 65. Now, let's try to answer this. I have here two items. Determine if any or one of them are divisible by 13. Okay? You may pause the video now. Okay, so I think you have the answer already. So let's do this. Last digit times 9. Okay, 9 times 4 is 36. 26 minus 36 is minus 10. So this is a very, far-fetched number compared to the ones we're looking for. So yeah, no, it's not. This number is not divisible by 13 in short. Okay, how about this? 572. So 2 times 9 is 18. 57, the remaining number, 57 minus 18 is going to give us 39. So is 39 divisible by 13? Well, yes, it is, because that's 13 times 3, 39. So therefore, we can say that 572 is indeed divisible by 13. Okay? Now, how about the last one? The last one we'll talk about is, again, fairly similar to the way we determine if one number is divisible by 13 or 7. What we have here is the divisibility by 17. So what did you do? Only that the multiple is changed. Instead of 9 in the 13, instead of 2 in the 7, we use 5 for the 17. Let me read that once. If the difference between 5 times of the last digit and the other digits is divisible by 17. So for example, we have 5, 4, 4. So we multiply the last digit, the ones digit, the units digit by 5. 4 times 5 is 20. Deduct that from the remaining numbers, 54. 54 minus 20 is 34, and indeed 34 is divisible by 17. That's 17 times 2, 34. So therefore, that's how you get it. So let's try to answer these two given integers and determine if they are divisible by 17. Okay, you may pause the video now. Okay, so let's try to answer. So here, let's start with 272. 2 times 5 is 10. 27 minus 10 is 17. So yeah, you can see that 17 is 17 times 1, right? So 17, so therefore we then ended up with 17, so therefore it is divisible by 17. This 272 is divisible by 17. How about this? 572. So 2 times 5 is 10. 57 minus 10 is going to become 47. Oh, okay, sorry, this should be 47. My bad, 47. Okay, and no, it's not a multiple of 17. 47 is not a multiple of 17 because right after 34, it will jump to 34. It will jump to 51. Okay, so it will not reach 47. Sorry, this is 47. My bad. Let me cover that. Okay, so this is 47. Okay, so that's the end of our videos in rules in divisibility. In particular, in this video, we have talked about divisibility rules for 10. That is very trivial. 11, the even and odd place values. 13, similar to 7, only that multiply the units digit by 9. 17, also similar to 13 and 7, only that multiply the last digit by 5. Okay, and that's it, the last part of our videos in rules of divisibility, and also a very important concept or topic in fundamentals of mathematics. Right up after this, we're going to talk about complete factorization. So some will call it in higher maths as the fundamental theorem of arithmetic, but let's just call it complete factorization for us. Okay, so that we'll have the terminologies as basic as possible. So yeah, thank you very much. Don't forget to like and subscribe. See ya.